Moving to the questions and discussion part of ionization energy. So, why ionization energy, second ionization energy is always greater than first ionization energy? This is an important and very common question. So, we have already learned that in the case of magnesium at gaseous state, when we supply 738 kilojoule per mole, which is the first ionization energy, become magnesium plus electron, right? When we are submitting magnesium plus another energy 1440 or 50 I2, it becomes magnesium 2 plus electron. They are asking why I2 is greater than I1 is because when the neutral gaseous atom we are supplying an amount of energy 738, it becomes Mg plus. So already the valence electron, one of the valence electron is removed. As a result of that, effective nuclear charge increases. Effective nuclear charge increases and the nuclear charge will pull or have an effect on the remaining valence electron and it will be pulled towards the nucleus center. As a result of that, we have to give more energy to remove the remaining valence electron. That is the reason why the second ionization energy is always greater than first ionization. You may also face another question, why I3 is greater than I2? That's also obvious because when the two electrons are removed, we have to give more energy to remove the core electron, the another valence electron. Because upon removing each electron, the nuclear charge will become increases. Because positive charge increases, the new proton, the number of proton is also increases. So as a result of that, we have to give more energy to remove the next valence electron. So I2 is always greater than I1, I3 is always greater than I2. In generally, we can say that In is greater than I1, where N is the number of electrons. N, okay. The second question, why ionization energy is increases across a period and down a group? This is a common question in plus 2 and in sometimes in MSc also seen that. It is obvious that across a period what happening? Nuclear charge, atomic number increases, nuclear charge increases because the electrons are added into the same energy shell, but due to the increase in effective nuclear charge, ionization energy increases. Down a group, what is happening? Due to the increase in the size, that is increase in the atomic radii increases due to the shielding effect also increases. Shielding effect also increases. Shielding effect increases, which means the core electrons shield or screen the nuclear charge from the outermost electron. So outermost electrons are free from the attraction of nucleus due to the shielding effect or the screening provided by the core electrons. As a result of that, ionization energy becomes less because very less energy is required to remove the outermost electron. So down the group, ionization energy decreases, across a period, ionization energy increases. The third question, first ionization energy of manganese is 7.43 electron volt and chromium is 6.76 across a period. Why? As you all know that manganese and chromium belongs to the 3D series. Across a period, chromium is here 24. Next element is manganese 25. So it is zinc. So general trend is that across a period, ionization energy must be higher. So general trend, we can say that chromium should have less energy. Chromium should have, manganese should have very high energy than chromium 24. The reason is that manganese electronic configuration, we have already explained it. The anomalies part, manganese is 25, argon 3D5 and 4s2, right? Whereas in the case of chromium, it is 24, argon 3D5 and 4s1. Okay. So this manganese having a half-filled d orbital and a fully filled s orbital. So we have learned in the anomalies part, and in the case of chromium having a half-filled d orbital and a half-filled s orbital. So half-filled, half-filled, fully filled, half-filled. So the stability of a fully filled half-filled subshell is always greater than a half-filled subshell. That's the reason why the ionization energy of manganese 7.43 electron volt is always greater than chromium. Okay. The fourth question is very important. You will be given a series of ionization energy order, and you have to write whether the order is correct or not. So here we have given a boron family or boron group order of ionization energy, whether boron greater than aluminum greater than gallium, which is greater than indium and thallium. So you have to first write the electronic configuration. Here I have write the electronic configuration. You can see that the boron, which is as a general trend, when moving from boron, aluminum, gallium, indium, and thallium down a group, ionization energy decreases due to the increase in the size. Right? Down a group, ionization energy decreases due to the increase in the size. So, boron is having very high ionization energy, which is obvious that boron is having very high ionization energy. And the reason is that because the core electron are very close to the nucleus, so the nucleus, effective nuclear charge is very higher in that case. So boron is having very high ionization energy. That's the reason boron is having ionization energy of 801 kilojoule per mole. So this one is correct. So boron is greater always. What about aluminum? So we will look into aluminum. So aluminum is having 3 is to 3 by 1. And look at gallium. So in the case of gallium, there is an additional d electron will come. And also see one d, two subshells. D subshell is also fully filled. S subshell is also fully filled. In the case of aluminum, only S subshell is there. And in the case of indium, after D, another D subshell is also coming. So in the case of D subshell, what is the charge of shielding effect? In the case of D subshell, the shielding effect is very poor. So, but which is having two fully filled subshells in the valence electron. So the ionization energy always higher in the case of gallium, right, than that of aluminum. Okay. Gallium is always greater than that of aluminum. But whether it is the right, see, we have to check indium also. 4010. When there is the number of shells are added into the atom, number of shells are added into the atom down a group, the poor shielding effect of d orbital, the Z charge, the effective nuclear charge increases, which will attract the valence electrons towards itself. So, indium experiences very less ionization energy than that of gallium because of the increase in the size. What about thallium? In the case of thallium, see, it is having one fully filled 4 subshell, one fully filled D subshell, and one fully filled S subshell. So, its stability is very higher. In addition to that, due to this belongs to the lanthanide. This thallium is also a follower of lanthanide series. In the P, after the D block, thallium is also a follower of lanthanide series. Due to that, the effective nuclear charge experienced by the thallium is also very higher, and the poor shielding effect of F orbital, the poor shielding effect of F subshell, and relativistic effect. Here see the atomic number is 81. When the atomic number is greater than 70, the velocity of core electron or the electron is attains the speed of light, and the velocity of electron is proportional to the effective nuclear charge. As a result of that, the nuclear charge very higher in that case. So ionization energy required to remove the outermost electron is very higher because it has to withstand, it has to overcome the charge of the nuclear charge. So we can write it as the correct order will be experimentally proven and the correct order will be boron and then thallium. Okay, and which Indian greater than gallium? Because when compared with the gallium and aluminium, gallium process one fully filled D subshell and one fully filled S subshell, and then aluminium, and finally indium. Indium is experiencing very poor shielding effect, and also indium is having D subshell. D subshell screening effect is very less, and okay, so this is the order, and experimentally it is found that boron is having 801 kilojoule per mole, and thallium is having 589 kilojoule per mole ionization energy. Gallium is having 579, aluminum is having 577, indium is having 558. This is experimentally proven, and the correct order will be boron greater than thallium, greater than gallium, greater than aluminum, then greater than indium. Okay, this is the correct order. So you should remember this order. We can also expect a question from a period also, whether correct or not. The ionization order of the third period, sodium starting from sodium ends in argon is also given. We have to check whether this is the correct order or not. Before before going to answer, we first write the electronic configuration. So I have write the electronic configuration of sodium. This is the core electronic configuration is of neon, which is a noble gas, 3s1, 3s2, and aluminum is 3s2p1, silicon is 3s2p2, phosphorus is 3s2 neon, 3s2p3, sulfur is 3s2p4, chlorine is 3 is to P5 and 3 is to P6. So the general trend is that ionization energy increases across a period due to increasing is a defective. Okay. So we know that sodium is always possess very less ionization energy because it is a metal and very active. What about magnesium and aluminum? Let's look at the electronic configuration. It is a fully filled, right? Fully filled subshell of S. Here it is one is fully filled and one is incompletely filled. So this will come here and this will come here. The ionization energy of always less. Ionization energy of aluminum is very less than that of magnesium. So aluminum will come here, magnesium will come here. Okay, and silicon is as usual. Silicon will go and here see the electronic configuration of phosphorus is one S or S subshell is fully filled, P subshell is half filled, and one fully filled. In the case of sulfur, one fully filled and one incompletely filled. So phosphorus is possess very high. This will come here. Phosphorus will possess very high ionization energy than sulfur. Chlorine is obvious that its ionization energy is very higher because of it has to require one electron for octet completion and argon. So this is the correct order. So the change will comes to magnesium, aluminum, phosphorus, and sulfur. Okay. So these kind of questions you may expect in another periods and other groups also.